Well, thank you very much to Electricity Forum, and we look forward to presenting today some information I think you will find very interesting. As I dive through this, I want to give you just a quick little background. I want you to understand that what we do at Iris is we like to provide solutions to customers, and we are in the safety and reliability space. We're doing a lot of refocusing on sustainability, helping people understand the big picture in industry today, what we can do to really make a difference in that area. And so to give you a little background on Iris before I really dive into Thermochromics, we're a solutions provider for infrared inspections, ultrasound, training in infrared and ultrasound, asset management with IoT sensors, services including infrared and ultrasound inspections, as well as site walks to determine inspection needs, window placement, and our Safe Connect line of Thermochromics, which we'll be talking about today. And as we kind of go through this presentation, you'll really see how in today's world, everything tends to get to the more complex. We try to, add engineering in and try to get the latest and greatest technologies in a lot of our solutions in general in the world today. What Iris has done is really provide a solution that goes from the very simple to the very complex. Everything from the thermochromic line that we're going to talk about today, all the way through the ability to produce sensors and put sensors into equipment to give us feedback. All of this is as we become more advanced and we see the need for more feedback and greater, information, there can be very simple solutions. There can be very complex solutions. Today, talking about the thermochromic line, we're talking about some very simple solutions. So let me dive right in and give you a little bit of a variety of information. We're going to talk mainly about Thermochromics today, but as a company, when we're providing safety solutions, it's one piece of the puzzle. And as we kind of dive quickly here through the different parts of this, what you'll see is that there's not only solutions that allow you to give 24/7 continuous monitoring, even with a thermochromic, but the way to visually see what's going on inside of a panel is most commonly done through an infrared window or an inspection window. And we're the world leader in providing these solutions as well, even customizing them, custom solutions for the end user. And we do this all based here in the United States. We do all our manufacturing here and production as well. And so we live in today's sunny Florida. We recovered from a couple of hurricanes in the last 3 weeks, but we're back and stronger than ever. When we talk about infrared, this really helps people understand visually what that really means. We, as humans, we see a very, very small spectrum of actual light. And so in that spectrum, we think we see all kinds of things, but the reality is we don't see gamma rays, X-rays, ultraviolet, infrared, radar, FM, TV, shortwave, all this light is out there, just only some of it's visible to the human eye. And so when we talk about infrared inspections, what that really does is allows us to see, it's really an extension of our human vision. It gets into this next wavelength of light, and that's when you can actually see infrared. Most of us are familiar with the movie The Terminator, and in that they used some very early uses of infrared and got it out to the public so people saw these images that were actually captured by infrared thermography, and it allowed the Terminator to actually see into areas that the human eye wouldn't have normally seen. So when we talk about this technology, it's not really all that high tech. It's just out of our normal range of what we can visually see. Same thing with ultrasonic, same thing. It's an extension of our ears. So I like to keep things as simple as possible because the definition of genius is taking a complex and making it simple. That was an Albert Einstein quote, and he really helped people understand that it's not making things more complex that creates really these amazing technologies and different things that happen in industry. It's really making them as simple as possible. And that usually leads to reliability as well. So let's dive into thermochromics today, since that's what we're here to talk about. As we talk about thermochromics, what's unique about what Iris does with this technology is that we have patented what's called memory effect or color lock. And so there's a lot of things that have been done with thermochromics over the years. I remember, and I'll maybe date myself a little bit, but that's all right. In high school, I remember having a shirt that was made by a company called Hypercolor. And this shirt, when you wore it based on how much heat your body was producing, it would actually change color. Or if you put your hand on your shirt and then removed your hand, you could see where your hand had been because it changed. And that was thermochromic dye that was used on that shirt. And they always would say, don't wash it in warm water because that could potentially damage the dye. Well, fast forward many years, and now we're using this technology in ways that are amazing in industry. But the problem typically, as with that shirt, when you remove the heat source, the color went back to its normal state. And if you did that with a device on, say, a electrical connection, if that connection got warmer and then the temperature went back to normal, then if without a color lock or a memory effect, that would actually go back to the original state. And you may not have seen it when it was in the over temperature condition. And so this color locking allows us to have a way for someone to visually see that something occurred at some point. And this is an indicator saying, hey, there's an issue here. Many times we'll pay a company to come in and do thermography, or we get called in to do thermography. And at the time that it's a little snapshot in time, it's whenever that inspector is in there doing that thermography, that's the readings at that moment. But what happened at, an hour earlier in the day, or maybe at 2 a.m., maybe there's an issue that continued to pop up and we can't tell when it's happening or where it's happening. And if you're not there at that exact moment, the best thermography equipment, the best thermographer can't capture an event that's happening at a different time. So this is a really easy way to give you an indicator saying something happened here, probably worth looking into a little bit deeper. So why thermochromics? Why is it such a big deal? Well, these pictures here are a pretty strong reason why. So this shows, the main picture there shows a substation room where there was an arc flash event and it blew out this double walled room. So big concrete inner wall, brick exterior wall, blew it clean apart. And, if you can imagine, if someone would have been in that room, the results would have been catastrophic. And so what we try to do is prevent some of these things from occurring. The intense energy that gets released in any kind of a energy event like this, an arc flash event, is just extreme. I mean, the temperatures are, 2 times the surface temperature of the sun. The forces are at greater speed than a bullet being fired out of a gun. I mean, this is really dangerous stuff. And we sometimes, have to get in and inspect the equipment, and we like to be as safe as possible. That's where really our line of inspection windows and even thermochromics come into play. So what's a thermochromic clip or some kind of a indicator? What is that really going to capture? And the reality is anywhere where there's an electrical connection, where 2 pieces are connected together, or there's some part of an electrical component that gets a lot of flexing or movement, vibration, what happens is over time, these connections can loosen or break completely. When you get a loose connection, what happens is there's a higher resistance that occurs, and that generates heat. And to the eye, visibly, you can't see it. To the ear, you will not most likely even hear that. Even if there's some slight working going on, you won't most likely hear that until it gets pretty extreme. But in this loose connection, what's happening is not only is it creating heat, but we're losing a lot of energy. And so these little quotes here from different sources show, loose connections in motors can be up to a 20% energy loss. 25 billion annually is being lost in poor electrical connections in the US industry today. Poor electrical connections in commercial buildings alone, $4 billion annually being lost. These are massive numbers and showing the real impact that loose connections are having, not only financially to companies, but also, the other side of that is the safety and reliability that can occur if these aren't corrected. And so we could just say, okay, let's have a maintenance program where we go in and tighten everything down. That's a whole nother conversation for another webinar at another point where we talk about the importance of reliability. But the correct answer is not tightening things, because that can create and actually inject another issue that can create, mortality or a failure situation. You could over tighten, and that can create another problem. You could actually work a connection that is totally fine, but actually create a problem with a cracked fastener or something like that. So many things. It's not just about retorquing or retightening. It's about finding that loose connection, and there's easy ways to doing that. We look for simple ways of diagnosing in our real world, and that's one of the things that, my example of the visual wavelength that we can see with our human eyes versus what's actually all around us that we can't normally see. We all, in everything we do, we like to take indicators to check health. We go to the doctor, one of the first things they'll do is check our temperature. And if the temperature is higher than the normal range, that indicates that there's probably an infection. In our car, we have just a handful of gauges in today's high-tech cars. We typically will have a temperature gauge, a gas gauge. We have sometimes indicators that tell us tire pressure. All these things are important things that we need to know as the operator of a vehicle or our human body. We're coming up on Thanksgiving, so I thought it appropriate to talk about one thing that's really similar to a thermochromic, which is a turkey timer thermometer. So this is a really simple device. Once again, the genius of man is taking the complex and making it simple. We used to have to stick a metal thermometer, metal probe thermometer into a turkey and check the internal temperature to make sure it cooked all the way through. And now pretty much every turkey comes with this turkey thermometer built in. And it's not just a indicator saying the exact temperature, just when it gets to this range, then this pops up, it's time to pull the turkey out, it's done. So once again, very simple. Anyone can do it. And that's really what the beauty behind thermochromics are. Thermochromics, and this is a visual indication, time lapse has been sped up, but here's 3 conductors coming into a disconnect or a circuit breaker. The one on the right ended up going through maybe a heavier load, whatever caused that to change color. And so that clip went from purple to pink. And even when the temperature is brought back down, it'll stay that exact state. So you can look in there maybe 5 months later and say, at some point, there is a problem on this phase, and we need to look deeper into it and maybe monitor it more closely. And I've got a couple of examples. I'll show you how that works a little bit later on. But these are thermochromic clips that simply just snap on to a conductor, and it can give you a very easy temperature indication. For conductors, wires that are larger in size than we make the different clips for, we make quite a few different sizes. These are actually a thermochromic product called thermal wraps. And what's unique about a thermal wrap is it can be put on any size conductor. It can either wrap around it, either around the diameter or lengthwise on the conductor. And these will actually do the same thing. They lock in at the temperature, and you can buy these in 2 different ranges. One is a 70 degrees Celsius trip point or a 90 degrees Celsius trip point. Based on your application, you can pick what temperature point is best for you. But what's neat about these is that you can quickly look at them. If it's still white, you know that it's not reached that 70-degree temperature at any point. And if it's gone over that, then that entire bar turns black and stays black. This is actually another thermochromic product that's very simple, very, very basic. And these change from the white, the dot on the left, to red, the dot on the right, at 52 degrees Celsius. And what's interesting about these little dots is that there's massive applications in even residential, light commercial, because there's problems that occur. Sometimes it's loose connections, but sometimes it's devices that are just being overloaded, or a device that's not operating properly. We show a picture there of it on a different devices plugged into an outlet strip. But let me show you really a picture. So what's happening here, this is a thermal spot on a device. And as the device ended up getting over 52 degrees, that dot in the center starts to change color. And once again, if you brought that temperature point back down, that dot stays solid red. So very simple, very easy to see. Anyone can look at that and say something's changed, something is wrong. Other applications that thermochromics that we've developed are utilized in are bigger applications, or definitely just a different form, really, where we're talking about bus bars, bus joints, bolted bus bar connections. So once again, these are set at 52 degrees Celsius. And the reason that that is a lower set point than the thermo wraps or the thermal clips is that you would not want a bus bar or a bus joint to get anywhere as close to 70 degrees Celsius. So these indicated a lower temperature, more appropriate with what would be known as a fault condition in one of these applications. And so these are stickers that would apply to any one of those types of devices and will quickly be a visual indication that there is an issue here. And in addition to that, they're actually really good targets if you're doing thermography. If you're doing thermography and you want to see the temperature of a bus joint or a bus bar, it's such a reflective surface that you would not get a great thermography reading back from that. There'd be too much reflection. And so these stickers can be applied. One, they give you an indication if the temperature has exceeded the set point of that sticker. And secondarily, you've got a very great target point for thermography. If you're doing additional inspections, or phase 2 of the visual inspection is then the thermography readings. So a lot of different applications, a lot of different products. This is a video, once again, this middle phase bus bar reached over 52 degrees Celsius. That square turned bright red and stayed locked in at that color. This is one of the other products in the thermochromic offerings that we supply. This one, though, gives you a maximum temperature. And so anywhere between 50 degrees Celsius and 100 degrees Celsius, this will go up to that range and lock at that range. So it's not just going to say, hey, it went over temperature. It gives you an exact temperature of what it did reach and then locks in. All the bottom blocks where that temperature has gone past, those will stay black. And so once again, you may have a combination of some of these clips, stickers, devices. Depending on the criticality of that asset, you can determine which one of these indicators makes sense, or maybe a combination of different indicators based on your needs and criticality. And this last product here that I want to cover here in the thermochromic line is the actual temperature. And so these get used a lot in conjunction with the other devices, the other products that we have, in that you can look and say, okay, at some point this reached over this set point of 70 degrees. But today, right now, when I'm looking at this, we're down, not even registering 55. So this gives you at that exact moment reading. It doesn't lock into a temperature. It just gives you the exact temperature of what that device is that it's located on at the moment. And this is kind of a unique thing, a little bit different than all the rest of them. This is actually thermochromic paint. And what's unique about this product is it can be applied to anything. So, and it gets used very often on like motors, different devices that can generate a lot of heat. This, once again, changes temperature, changes color at 70 degrees Celsius. You just put the bottle on the right has a brush actually located in the cap. You can go around kind of like the old whiteout days where you put a little dab to cover something up. This is kind of a similar thing. The paintbrush is a little bit bigger than what a whiteout container used to have. But you just brush on, the bus bar or whatever you want. The squeeze bottle on the left works the same way. We sell it in tubs as well, based on, how much you're doing and all the rest of that. But it gives you the ability to see when you apply it, it's a light pink. After it reaches past that set point temperature of 70 degrees, it turns red and stays red. It's a color locking paint. So really cool, unique products. And the industry is just, every time we talk about these, people just rave. This is actually a combination of things. The middle gives you a picture of thermochromic paint, and then on the left, that's an actual temperature gauge, and then the one on the right shows you actually the most temperature it ever reaches up to and locks in. So time-lapse photography, you can see the actual clock on the right. But this kind of gives you, without waiting all day, how this works. The right is actually a thermochromic image So you got a thermography camera on the right showing the temperature starting to come up. And then on the left, you actually what is real-time visually able to see with your eyes. The thermochromic paint in the middle is now turned red. The temperature gauge on the far left is saying we're past 70, reaching 75. The gauge on the right is showing you the actual temperature of where it currently is. And as the temperature continues now to go down, you'd see those numbers dropping on the actual temperature, but the locked-in paint and the locked-in temperature gauge on the far left staying at the highest temperatures that those achieve. It's just really cool to see kind of real life how that would work and what they look like after the temperatures have changed. To give you an idea of really the thermochromic clip side of things, we sell it in a variety of different packages based on the client's needs. This is what we call our service kit. So when companies usually start working with this product, they're not sure of maybe what they're going to use. We do sell each size individually in packs. We sell smaller service kits as well, but this one really gets someone started. They got a variety of clips, some of the wraps, and a jar of the thermochromic paint. And so you can start applying these, seeing what you like to use, how they work best for you, and then decide, hey, do I need to refill a certain size or buy more of a certain size? It just gives you lots of options and a really good starting point, so you can really see this in use and see how their valuable feedback that they give you very quickly. This next video I'll play for you here shows a thermocouple that is underneath a thermocouple clip, a thermochromic clip. And so as you see on the meter on the far left, when I start the video, you'll see the temperature start to rise. When it gets up to around 70 degrees, it'll start changing color. Then you see the temperature will come back down, and you'll see that that clip then stays locked in at the lighter colored pink. Once again, time-lapse photography, but right now we're getting up to 60 degrees Celsius. That clip starts to change color. And then what we'll do is we'll drop the temperature back down again. And then as that temperature drops down, you'll see on the reading, but the clip stays pink. So super visually easy. You can have anyone who's even an untrained, electrician, who's someone who's not an electrician, untrained, could look at this and say, hey, all these other clips on the top are all still purple. This one in the middle, there must be an issue there. They can alert someone else. And we call it operations-driven safety and reliability, or operator-driven safety and reliability, where the people that are around equipment day in and day out can actually give great feedback back to people who are in charge to say, hey, I don't know what occurred here. They don't need to know. They just need to know there was a problem. Here was actually a real-world example. We had these thermal clips at a customer site, and they were having problems with their chillers. They did not know what the issue was. We put these on there. They found exactly where the problem was. And they went back in, did a thermography reading. That's the image on the right. And so, man, we've got some really hot conductors here. There's some issue. They traced it back. We're able to find the problem and actually solve an issue that's been bothering them for a very long time. So in the real world, works great, solving problems that they, sometimes, once again, these problems could be occurring in the middle of the night when there's no one around, and there'd be no easy way to really finding the issue or knowing what happened. This, and really here's the other piece of the puzzle here. And this is one of the reasons we're getting so much traction with this thermochromic line. Number one, simple, inexpensive, 24/7 continuous monitoring. It's one end of the spectrum. I mentioned earlier we have a product line with our IoT sensors, and that whole piece of our business, very high tech, very cool 24-hour continuous monitoring as well. Just different parts of the spectrum. One thing that's cool about, even if you have a monitoring system where you're using devices or IoT sensors, you may get feedbacks or an alarm triggered that says, hey, there's an issue, there's overheating, there's something going on here. If just based on that one bit of information, you went back and then had to shut equipment down, you may have had a faulty sensor. You may have had some condition that wasn't an issue with, say, the electrical system. Maybe it was something happened that triggered that sensor to give you an alarm. If you had the perfect combination of Safe Connect clips, iris inspection windows, and a very high-tech IoT system that gave you this feedback, you could not only get this alarm trigger, but then you could go to the equipment, the asset, open up your inspection window, visually look in and see if the thermochromic clips that you had inside there changed color, or the paint that you'd applied to the bus bar had changed color. Then you have, double assurance that if you shut this equipment down, it's for a good reason, not just shutting it down because maybe the sensor was faulty. So you're getting a lot of different duplicated confirmation that you're making a good decision by taking this equipment out of service. And here's kind of where all this also comes into play. The standards have changed. NFPA 70B 2023, they changed from recommended to shall be. They changed the wording. Shall be is the strongest form of you must do this. It's a legal way of saying this is not an option anymore. And so when you go through the different parts of 70B, I just highlighted a few of the different chapters here. Each one of these chapters says visual inspections shall be conducted. At a minimum, it's a yearly inspection based on the condition of the device. Sometimes you're required to do it more than once a year, but at a minimum, it's once a year. And so some of these require visual, some of them are visual and thermography. But if you just did a visual inspection, say you open up the panel door, take a look, what are you really looking for? Some major, wire hanging loose or something like that, like a visual inspection quickly done, you're most likely not going to see much. But if you had thermoclips in that panel, or you had paint on different components in that panel, at a visual inspection, you would actually get to see, hey, we actually do have an issue here. We need to look deeper into this. It could save you tremendous amount of money and potential downtime, or a condition that could have an asset failure or cause some kind of human life condition. And so these visual inspections that are now mandated by NFPA 70B are real. They're expecting us to not only do these inspections, but document this as well. And that's where some of our asset management software comes into play. And companies are saying, yeah, but where's the teeth? OSHA's not going to do anything about it. And some of that is true. But the reality is, and we were just at a major new utility in Michigan about a month and a half ago. We were called in because their insurance provider said, we need to see the documentation that you're following NFPA 70 requirements. And so they were saying, wow, we need to scramble. We need to they actually hired a reliability engineer. The reliability engineer said, we need iris in here. I want iris windows so we can do inspections. And then we discussed thermochromics, the advantage of not only doing a visual and thermography, but now you actually have this other system that's really doing 24/7 continuous monitoring. So when you do the visual inspection, you can actually see that there was something either completely good or there's an issue here somewhere. So NFPA 70B is going to be enforced, in my opinion, more and more and very rapidly by insurance providers, because they're looking for their way that they don't have to pay. If they're insuring a facility, a large company, and that company is not complying to standards that are set, that's their way out. If they can get out, they will. And if they're insuring somebody and there's an incident, then they need to make sure, hey, we've done what we were asked to do. So that's where all this really comes into play, and why we're seeing such a strong demand for this in the marketplace. I love this quote by Edwards Deming. Your system is perfectly designed to give you the results that you're getting. And so if you're having issues in your facilities, if you're having downtime, unexpected, shutdowns, or you're having equipment failures, it's the way your system was designed. And you may say, well, I didn't design the system, but you now have the ability to do something to improve your systems. And that actually is part of NFPA 70. Not only when you look through the hierarchy of controls, the idea is to provide more and more safety by reducing risk to human life. But part of it is putting things in place where you can do more to actually engineer safety into your equipment and assets. And so we are responsible for, if not designing systems, to improve the systems that we have responsibility for. And so with all that, I really want to wrap up by saying, we have so many really cool things in technology today. There's so many different areas that we have the ability to, make better, to improve on using technologies that, we didn't have access to only a handful of years ago. And now as we get, these different technologies, we can marry them all together from simple to complex and really get a real clear indication of what's going on within our electrical assets and also being compliant to the standards that are set out before us. As engineers, and in my introduction, I was introduced as a recovering engineer, which I am, kind of jokingly. It's my start was at a company, I won't say the name, but the initials were GM. And in those days, I got to see firsthand, the good and the bad, the things that occur day to day on the lines. As an electrical engineer, walking up and down the floor, seeing things that could have been prevented, but they did not always want to shut the line down. It was so critical to get parts out the door. But when things failed, they failed big because that problem usually built up. It got worse. It didn't get fixed until it was too late. And then they didn't have a choice but to shut things down. But at that point, the expense and time involved in correcting a major failure, a big fault, is sometimes just uncomprehendable. It's way worse than if you'd tackle it up front. And what we like to promote as a company is condition-based monitoring. So that way, when a condition is saying, hey, there's a problem here, now go in and fix it. It's not about time-based maintenance in most applications. Most applications, that's not the issue. The real issue is there an issue that we can identify? And if there is, can we get in there and do something about it before it causes a problem? We want to provide safe and reliable situations. That's why our customers love our company. We provide the best in class in all of our products, not only in the quality of the manufacturing, the quality of the materials used in all of our products, the lifetime guarantees. All these things are what make Iris really unique in the marketplace and stand out head and shoulders above our competition. The owner of the company, Martin Robinson, has done a phenomenal job, really, from the early days of working out of his garage and creating products that were not only something he could use as he was doing thermography, but then to the bigger world in general, where he's like, we've got to provide more safety. We want to be, the leaders in reliability, sustainability. And as we continue to spread that message decades later, he is actively involved in every step of this process, helping us expand this literally around the world as we have offices in Qatar and India. We have, presence all over the world in every part of the globe. And as we continue to spread this message of safety and reliability, sustainability, products like Thermochromics will help us do that. And so I encourage you, if you have not looked into Thermochromics or the solutions that we provide, go on our website, look around, and then if you have any questions, contact us. We'd love to help you and your facility be safer in 2024 and as we approach 2025. Once again, I've enjoyed sharing with you today. I hope you found this very helpful.
Thanks very much, Mark. Appreciate the presentation. We do have some questions. Okay, the first one is from Dervinder. How long or how far does the actual temperature have to be above the temperature set point in order to change the color of the tape or indicator?
That's a great question. One of the videos where we had that thermocouple tied underneath, or just, the wire was underneath the thermal clip. If you're watching the meter, and what happened was, as that meter got right around, I was watching the meter very closely. When that got right around the 70-degree point, which is the trip point for that clip, it started gradually starting to change color. And as that temperature went past that point, it continued to change more of that color. The reality is, if it just barely nicks that temperature point and then comes back down, it may only change a portion of that clip, but you'll see that that clip was experiencing that trip point temperature. So it's within I'd say within a degree or two, you'll see that starting to change color. If it goes substantially over that or at that temperature for any length of time, that entire clip will have absorbed that temperature and change color and lock at that changed color.
Okay, thanks. Next question, how safe is it to install these tapes on bus bar? Is there a risk of fire? If they are installed and a fault is indicated, is it easy to remove and replace them after correcting the fault?
Yep, also great questions. And so I'll do my best to go through those kind of as you ask those. So well, let me start with the back and I'll work forward. To remove them, if one shows, hey, there's an issue here, because it's locked, you do have to remove that. And a simple scraper, knife, you can sometimes peel them off with your fingernail. They're extremely strong adhesives, so that it does take a little bit of work to get them off, but it's nothing very extremely difficult to do. And so peel one off, put a new one on. Refresh my memory, Randall, what the other questions were.
So how safe is it to install on the bus bar? Is there a risk of fire?
Yep, perfect. So as far as safe on bus bar, obviously you'd want to turn the power off before you apply this to a bus bar. And so, it'd be de-energized gear. Then you could apply this onto a bus bar safely and obviously test before, even after you remove the power, test to make sure the power is off and then apply that safely. The risk of fire, these are not flammable, and there is no risk of fire when you put these on an asset.
Okay. Next question, how accurate also are the results? How accurate are the results? Are they 100% accurate and precise?
We've done extensive testing. The actual, color changing technology has been around for a long time. What's really unique about our product is that it locks at the temperature, but also that we've used very high quality ingredients, components in our products. And so these have been tested extensively, and we look for, they're tested even amongst the batches when they're produced. Certain numbers are pulled out, tested to make sure that they work properly and are reliability and have high sensitivity to the points that they're set at.
Okay. Is the color change on the clips based on excessive current flow or a loose conductor connection on a device terminal?
Yep, so it really is not current dependent, it's temperature dependent. And so most likely, it would be caused by a current flowing through high resistance, which would create the heat. But the color change is occurring based on temperature, not directly tied with current. You could have a large conductor properly sized and have, tremendous current flow. And as long as that wasn't creating a significant heat source, then you could be flowing large amounts of current through a conductor if it was sized properly, would not create heat.
Okay. Next question. Do you recommend having both the IR windows as well as the IR stickers? If yes, where should I install the IR sticker in switchgear?
Yeah, it's actually an excellent question. So one of the things, if people don't have inspection windows, infrared windows, the problem is that every company has their own safety standards. Some companies do open panels when they're energized. Obviously, the code requires you to be suited up, appropriate gear with appropriate standoff distances. But the reality is, as soon as you open up a panel, you're changing the condition inside the panel. And so if you're doing thermography readings and you're doing it by opening the panel or removing a panel, you're actually changing the internal temperature. You're not getting an accurate reading. If you're doing it de-energized, once again, you're not getting an accurate reading at all because now there's not, the condition has changed. And so you're not getting the information you're hoping to achieve. The ideal combination would be an inspection window, and if the inspection window is already in place, there's obviously a certain field of view that window will give you. that calculator that shows you the field of view is available on our website. But the field of view then gives you an indication of how far back you are, how wide you need to get in and see. And based on what you're viewing, your angle of viewing is, and how much a size that you have when you look through that window is where you would place that sticker. Ideally, you'd put it close to where there's a electrical connection, or a connection of some point. That's where typically heat would be generated. And so you put that sticker or clip in a direct line of sight from that inspection window, or as close as possible to a direct line of sight.